going to begin by showing you the different parts of the arm. Here's the anatomy of the bone structures in the arm. Starting at the top, we have the digits, which at the top includes the phalanges, this being distal, middle, and proximal. And then on the thumb, we just have the distal and proximal since there's no middle phalange. And here we have the metacarpals connected to the carpals, which is connected to the wrist through the ligaments represented by tape. The ligaments on the hand are represented by these white colored pencil lines. Next, I'm going to talk about the forearm. So we have the forearm. On the distal side is the ulna. On the proximal side is the radius bone. So the forearm is composed of two separate bones, even though it's represented by one cardboard piece here. And also the ligaments connecting the forearm to the upper arm are also represented by tape. And the upper arm is called the humerus. Now I'm going to show you how my arm actually works. So I'm going to start with the hand. We have the flexor digitorum superficialis, which pulls the fingers so that they flex forward like that. As you can see in the video, they're being pulled forward and flexed. And something that flexes that whole hand into a fist is the palmaris longus. As you can see here, the wrist is now moving towards you, which is also known as an adduction. So this is controlled by the flexor carpi ulnaris. As you can see here, the wrist is abducting away from you, which is controlled by the flexor carpi radialis. Though I do not have a tendon representing the extension and the flexion of the hand at the wrist, my model was still able to perform these actions, and the tendon that would perform these actions in a normal wrist would be the extensor capri radialis brevis and longus, as well as the flexor muscles, which I discussed earlier. These flexor muscles would pull the wrist forward, and the extension would pull it backwards. Here we see the forearm flexed at the elbow by both heads of the biceps brachii. Another muscle responsible for flexing the forearm at the elbow is the brachioradialis. Here you can see that the shoulder is being lifted by the clavicular head of the pectoralis major. Here we see the thumb working like a saddle joint, where it can be flexed, extended, or even pulled back and forth to abduct or adduct. Now I'm going to be showing you the modifications I made to fix my arm so it's easier to use. So the first edit that I have is this extension to the arm. This is very important because originally I had my person hold the arm under their armpit with this long box, which was really uncomfortable, and it fell out a lot because of how thick it was. So I had to make it thinner through this. Another modification I had to make is these straws. I had to add a lot of these straws across the entirety of the arm, because without them, all of the strings would get tangled and it would be a big mess, and I couldn't tell the strings apart, and it was getting really complicated. Another thing that I added to tell the strings apart were these colors onto the edges of the string. I added red, orange, pink, and green in order to tell which part of the hand I was pulling. So another modification I had to make to my arm was actually adding a shoulder joint, because originally my arm would be like this and then bend up, but it would be too difficult to physically get it to the mouth. So by adding a shoulder joint, it just made it that much easier. Another issue I had was actually getting the arm to bend up and like this with the weight of the cup. The cup would add a lot of weight and then the arm would start to go backwards and wouldn't want to pull up no matter how hard I pulled. So I added these little boba straws with string through them so that it would actually, if you can see, pull this area tighter without me having to physically pull it tighter. Same with here. So this one would pull the wrist joint up tighter and this one would pull the shoulder joint up tighter. Another modification that I had to make was getting the wrist to move back and forth. Originally I had the wrist just be stable and move forward and backwards, but then I realized that wasn't necessary for what I needed it to do in my project. Instead, I needed it to move back and forth, so I needed it to abduct and adduct. So here you can see I added this tendon right there, which would pull the wrist this way. And then I added this tendon in the back, which would pull the wrist the other way. That way it was easier for the person to twist the hand as they're drinking the cup, because hand would go up like this, and you could twist it so it doesn't spill, and then twist it so you can drink it. Another modification I had to make to my hand is fixing the thumb, and in order to get it to move back and forth, I added a little brad so that it can twist easily. Now I'm going to show you how my arm works to pick up a cup of water so someone can drink it. No! It's sideways.
I know, that's what back. Turn it.
Can't do that. One second. Got.
Hold.
I'm pulling it. I'm pulling it.
I got one.
Yeah.
Okay, put it down.
Thanks for